everybody, welcome to Maths IEC. Today we are going to discuss an exam question. Now this is a popular exam question for GCSE physics. This is directly related to the required practical about measuring the density of an object. Please pause the video, give it a try, come up with your answer to the best of your ability, and then you can press play and check your answer against the mark scheme. A student wants to calculate the density of the two objects shown in figure 2 below. Metal cube, irregular rock. Describe. The keyword or the command word here is describe. Now that's an important thing to notice. How the student could measure the densities of the two objects. Right. So the things you need to think about here, just to plan your answer, is that density is mass over volume. So that's how you can calculate the density. Measuring the mass of each one is easy. All we need to use is we can use a top fan balance. So that can be measured. So how do you find the volume? Now, the volume of the metal cube can be measured if you can get the length, width, and height. Because it's a cube, I know they are all equal. All you need to do is just measure them using a ruler and multiply them. So that will give you the answer. In this case, it will be x cubed. What about the irregular rock? So for the irregular rock, we have to use either a measuring cylinder with water in it, or you can use a Eureka can. Let me show you both options. So here's how you measure the volume of the irregular rock using a Eureka can. What you need to do, you take a Eureka can and you put it on a support, and you have the spout of the Eureka can, and you can keep a measuring cylinder. Then you need to just fill water in the Eureka can. Now when you fill the water, it will only get filled up to this point. Because it's obvious, any water that goes above it will go out from the spout. So the water will go up to that level. So basically what you practically do is, you take the Eureka can, and you keep such that the spout is kind of towards the sink, and you just fill it a little bit over, and what will happen is the excess water will drip away, the excess water will go away, and it will go down to exactly the level of the spout and stop. And now you can put it on a support like that, and then you can take a measuring cylinder, make sure it's a clean, empty one, and then you bring it here. Then you need to carefully lower this using a string into the Eureka can, like into water, like maybe that. So obviously when you do that, what will happen? Water will come out from this, and it gets filled up to a certain level. Now, the volume of water that gets filled in here is exactly equal to the volume of the irregular rock. That's how you can measure the volume of this irregular rock using a Eureka can. So here is the second method of doing this one. So you take a measuring cylinder and you fill water up to a certain level. Then, if this reading is V1, you just read that one. And then what you do, you take the rock, and you're going to again connect it to a string and carefully lower it like before. Now, when you put the rock inside, obviously the water level will go up. Now let's say the new reading here is V2. So how do I find the volume of the rock? Volume of the rock is the difference between the two readings, V2 take away V1. Now to measure the mass, we always use a top fan balance. Now this is really important. Now some people use the word scales or just balance. You might get away with some of these words, but the best way to say it is in a more scientific manner. Just call it top fan balance. Now let's write like a model answer to get full marks. Right, so this would be the expected answer. So let's see what you can write. To measure the density of each object, the student needs to measure the mass. A top fan balance can be used to do this. So that will be 1 point. The student can use a ruler to measure the dimensions. The student can use a ruler to measure the dimensions of the cube and use volume equals length times width times height to get that. That will be one thing. Or you can simply say volume is equal to x cubed or something, a cubed, whatever the length, cubed, because they are the same. Fill a Eureka can with water and slowly lower the rock tied to a string and collect the water displaced using a measuring cylinder. This volume is equal to the volume of the rock. Alternatively, the student can fill a measuring cylinder with water and record the initial volume. We called it V1 earlier. Then submerge the rock and record the new volume. The difference gives the volume of the rock. That's another way of saying it. Then density can be calculated using the formula D is equal to M over V. Density equals mass over volume. So you'll get marks for saying the correct equipment, for saying the formula, and for the procedure, all of that.